Hey, Flick Frenzy Fest, Puck here. Ever looked at a simple plastic object like a toy or a bottle and really wondered where it came from? Not the store, not even the factory, but its deep, deep origin story. What if I told you that the plastic in your hand, it actually started its life millions of years ago as microscopic creatures swimming in prehistoric oceans? Today, we're unleashing our curiosity and going on an epic journey to uncover the hidden, mind-blowing process of how plastic is really made. From the ancient, gooey heart of the Earth, through these colossal factories of fire and pressure, all the way to the everyday objects that shape our lives. This is a story of industrial alchemy you won't want to miss. So, let's get started. Okay, so our journey begins deep underground with crude oil and natural gas. This dinosaur juice, as some call it, well, it's a thick black cocktail of hydrocarbons, basically the fossilized remains of ancient life. It's a treasure trove of energy, right? But for our purposes, think of it as a massive jumbled up Lego set. And our first job is to break it down. That takes us to our first stop, a colossal refinery. I mean, it's a sprawling city of glowing pipes and fiery towers. Here, in a process called cracking, the crude oil is heated to, get this, over 400 degrees Celsius. Excited, this intense heat and pressure, it cracks the long, complex hydrocarbon chains into smaller, more useful molecules called monomers. You can think of them as our individual Lego bricks. The most important ones for plastic are ethylene and propylene. So we've broken down our ancient Lego sculpture into its core bricks, but how do we build something new? That's where the real magic happens. We've arrived at the heart of the plastic factory, the polymerization reactor. Inside this chamber, you've got billions of our tiny monomer bricks, and they're mixed with a special catalyst. And then, wow, a chain reaction ignites. The monomers begin to link up, one after another, and they form these incredibly long, strong chains called polymers. It's like, imagine stringing a million paper clips together to form one single, massive chain. That's a polymer. And these chains, they are the very essence of plastic. This whole process creates a river of glowing molten plastic. As it cools, it's chopped into tiny uniform pellets, and these are called Nurdles. And these Nurdles, they're basically the universal currency of the plastic industry. Yeah, they get shipped to factories all over the world, ready to be transformed into, well, almost anything you can imagine. So, the question is, how did these little Nurdles become, a phone case or a car bumper or even a life-saving medical device? It all happens in this final, really satisfying stage. The Nurdles are melted down again, right? And they get mixed with pigments for color and special additives to give them specific properties, things like flexibility, UV resistance, or extra strength. Then the molten plastic is forced into its final shape. So for a bottle, for instance, they use a process called blow molding. It's where a tube of hot plastic is inflated like a balloon inside a mold. And for something more complex, like a Lego brick, they use injection molding. That's where the liquid plastic is shot at high pressure into a really precisely engineered mold. It's a dance of heat, pressure, and speed, repeated millions of times a day. And here's a fact it'll just make your jaw drop. Humanity produces over 380 million tons of plastic every single year. Wow, that's roughly the same weight as the entire human population of the planet. But, as we marvel at this ingenuity, we have to acknowledge the flip side. The very quality that makes plastic so useful, its incredible durability, well, that's also its biggest problem. Most plastics just aren't biodegradable. They persist in the environment for hundreds, even thousands of years, and they break down into these tiny fragments called microplastics. And these particles, they've been found everywhere, from the deepest oceans to the highest mountains, and yeah, even within our own bodies. So as we explore this process, we also uncover a grand challenge for our time. The same human ingenuity that created this miracle material, it's now challenged to manage its life cycle, Scientists are working on creating new bioplastics, stuff that can degrade naturally, and engineers are designing more efficient recycling systems. The story of plastic it's still being written. When you think about it, the plastic age is incredibly young. The first fully synthetic plastic, Bakelite, was invented in 1907 by Leo Baekeland. In just over 1 century, we've gone from a world with virtually no plastic to a world utterly dependent on it. It's a powerful reminder of how quickly a single clever process can reshape civilization. So, next time you pick up a plastic object, I hope you see it a little differently, not just as a simple thing, but as the end result of an incredible journey, a journey from ancient life through the fiery heart of a refinery to the microscopic dance of atoms, all to create the material that defines our modern world. Now, here's a question for you, our fantastic Flick Frenzy Fest community. Knowing the full story of plastic, from its creation to its challenges, if you were an inventor, what kind of super material would you design to solve one of the big problems plastic creates? So, what would it be made of? What would it do? And what would you call it? Let us know your most creative, world-changing ideas in the comments below. We can't wait to see what your curiosity unleashes. And as always, stay curious.